Hi guys, now that we've taken a couple days to research about the different climates and how our atmosphere works normally and predictably, we're going to start looking into those things that change the atmosphere for the worse. So we're going to start looking at the human impacts on the atmosphere. Today we're going to start out small by researching some air pollution or going through a lecture. If you notice on Canvas, if you're in person, you've already got a copy of this in your notebooks. If you are an online person, you've got an editable copy right here. You can edit it right there. Or if you'd like, you can print it out and make your own copy. Either is fine. When you're done, you can either take a picture of it or submit the document itself, whichever works, as long as I can see that you have all those notes on there. Again, just a reminder that starting next week, I'm going to start putting the video lectures inside the actual assignment so they're easier to find. They won't be on the module section anymore. Here we go. So I want you to take a second and look at these different words right here. We've got, actually to change the view. We've got a couple of different or common things that we could find in the air. I want you to kind of predict which ones of these might be considered air pollution. We've got cow farts, nitrogen oxide, water vapor, ozone, sulfur dioxide, and carbon dioxide. Which of these, and it could be more than one, are considered air pollutants? I hope you've identified at least carbon dioxide. That's a very hot topic word in the climate change vocab. So that's an air pollutant. So is sulfur dioxide. That's actually what causes acid rain, which we'll study in a couple lectures. Nitrogen oxide is also an air pollutant. The ozone is an air pollutant, one type of ozone. Tomorrow we're going to discover that we have a good ozone, which protects us from UV rays, and a bad ozone, which is found in the troposphere, and we also call that smog. So the smog is what we consider an air pollutant. Cow farts, or methane, is also considered an air pollutant, and it is a greenhouse gas, meaning that it's causing the earth to warm up a little bit more now that we have more in the atmosphere. And surprisingly, water vapor is also an air pollutant. Too much water vapor, again, can lead to an increase in temperature on the earth. Good job. So now we're going to start in with our notes. I've got a question for you. What are the negative impacts of air pollution? In general, when we say pollution, we get a negative connotation, we get a bad feeling about it, but we have some very specific impacts that happen when our air is polluted. Very first and most often what we're worried about most is human health. It can decrease because of air pollution. It's harder to breathe, we get sick more often, maybe we can't get the sunshine that we need, so that's a negative. We can also decrease our visual quality of the environment, so maybe it's not harming anything, but it's an aesthetic thing. It's not likely that you're going to go visit an area that is covered in smog and full of pollutants. It can definitely decrease our water quality. So as those air molecules interact with the water molecules, we get an exchanging of gases. So those gases can be absorbed into our water systems, which is not good. Think back to our hydrosphere and how the carbon dioxide increase in the oceans actually causing a increase in acidity or a decrease in pH of our ocean, making it harder for some of our pH-sensitive organisms like corals to live, so they're dying out. We can also see a decrease in the health of vegetation in our soil, and we can also see a decrease in health in some of our animals, again, especially those sensitive ones. And then lastly, air pollution can cause an issue with our natural and artificial structures, specifically when we talk about acid rain. So again, we're going to spend a whole day talking about that, but acid rain, in short, is regular rain that comes down through the sky, but that sulfur dioxide bonds with that water vapor, making it a very acid-based or an acid-heavy raindrop, and that can actually start to eat away at our structures like our national monuments, our buildings, what have you as well. So those are all some of our negative impacts of air pollution. Moving on, we have a couple of types of air pollution, so specifically three. The very first one is an area source, and those are things or types of air pollutants that come out of very specific areas. So for example, our cattle ranch can increase our methane concentration. We can identify that that air pollutant is most likely coming from that cattle ranch, or really any kind of large-scale livestock farming will have that methane production. Also, our landfills produce a lot of methane, so that's an identifiable area that is common for polluting the air. Factories could do the same thing. Any of those could be examples. Moving on, so this is a little bit different, same, some of the ones we talked about before in the slide can also fit into this category, but another type of air pollution that we have is called stationary sources. So they're relatively fixed in location, they're not moving. These things can be housing residences, factories, and often we identify these as point source pollutants. If you think back to our hydrosphere unit, when we identified point source versus non-point source pollutants are things that we find or that we can identify exactly where they came from. Remember, we can point to what or who is polluting the environment. Just like with our hydrosphere, we can do the same with our atmosphere pollutants. Our other type of air pollutant here is mobile sources. These are often, again, non-point pollutants, so they're harder to identify exactly where they came from. They move from place to place, so these are a lot of our transport things like airplanes, boats, cars, buses. Those can all pollute the air. Again, just to review our bell ringer and kind of make sure we've really got this down, we have listed here 7 major air pollutants. Sulfur dioxide, which again causes acid rain, nitrogen dioxides, carbon monoxide, the emission from our cars, buses, that ozone, that bad ozone or lower ozone in our troposphere. Remember, the stratospheric ozone is good. We're going to learn about that in another day. VOCs are also possible air pollutants. Particulates, so even just dust and ash. Remember how we talked about how when volcanoes erupt, we can get dust and ash. We often do get dust and ash in the air, and that not only can block out the sun and lead to a decrease in photosynthesis, but it can also make it harder for organisms to breathe. And then again, lead. Lead can be a possible air pollutant as well. So this is another way to kind of classify our air pollutants. Before we talked about mainly where they come from as far as classifying. And these two scenarios, scientists have classified them based on how they react with the air itself. So our very first category is primary pollutants. Primary means one. So these are pollutants that are emitted or put into the air, directly into the air. So no chemical modification is needed for this to be an air pollutant. It already is when it goes into the atmosphere. Some examples of these are hydrocarbons and particulates. Remember we talked about particulates, dust, ash, sediment. And then on the flip side, we have what we call secondary pollutants. Secondary pollutants are produced through reactions with primary pollutants or things emitted directly into the atmosphere and the atmosphere itself. So that means that at some point in time, we have a chemical reaction happening between the atmosphere and the pollutant that was put in the air, and that is what is polluting the air now. Our examples of those are ozone and acid rain. Let's talk about acid rain for a second. Remember, acid rain happens when sulfur dioxide mixes with water vapor, or that condensed water. Actually, it is a liquid at this point. And then when that sulfur dioxide mixes with that water, it rains, precipitation happens, and with it comes that higher than normal acidic water, which can eat away right now it's eating away at buildings, but scientists are wondering, what if the acidity increases so much that it starts harming living things like plants, animals, or even humans? So that's something to think about as the state of our world gets dirtier and dirtier, maybe how your generation can change what's happening right now. And lastly, we have some factors that influence our air pollution. Very first one is topography, so whether there are hills and mountains in the area. Second one is local climate, considering temperature and humidity. Oftentimes, air pollutants are going to be worse in places where the temperature is higher and the humidity is also higher. A lot of that has to do with, remember, humidity is how much water vapor is in the air. So if we have a lot of water vapor, it's likely that we are going to have quite a bit of air pollution, or that air pollution, at the very least, is going to stick around longer because it has to travel through all those water vapors. Population density can also influence air pollution. A lot of people generally means a lot of pollution, whether that be in our air, whether it's trash, whether it's in our water system. So as our world population, or even if you think about the difference between pollution in a city and pollution in a rural area like what you live. So our population really plays a part in our pollutants. Number 4 is the amount of industry. Again, same kind of idea with population. More factories equals more pollution generally, unless they are environmentally focused, or at least have an idea of their environmental impact. Number 5 is fuel, whether that be, again, industry or population. How many cars are driving? How many airplanes? How much power is it taking? Are we emitting water vapor into the air with our steam, whether that be our coal production of power or our nuclear production of power? The weather, again, can play a part in our air pollution, so whether it rains, if it's windy, if it snows. Buildings can slow wind speed, so they can increase air pollution because the slower the wind, the more able we are to pollute the air. How many mass transits are used can influence the air pollution. Now that can kind of be a good thing and a bad thing. When we talk about using trains and subways versus everybody having their own individual car, we can have a difference. So carpooling is good, and using mass transits as far as like buses and trains and subways are generally better for the environment, but only if those mass transits were built with the environment in mind. So are they efficient machines, or are they, again, polluting the atmosphere? And then lastly, economics can even play a part in the air pollution. Okay, that is about it for your notes today. I hope you enjoyed. If you have questions, let me know. A lot of the things that we talked about today, we're going to go into more in depth later on in lectures. Like I said, we're going to be talking about ozone, we're going to be talking about acid rain, and we're going to really talk about the greenhouse gases as well. And then eventually, towards the end of the unit, we're going to discuss how all of these things come together and are contributing to what we call climate change. All right, guys, have a great day.